So we don't have to just manipulate basic functions, right? We can manipulate any function I see, no matter how complicated or how simple, and we're going to basically demonstrate that with these next two examples. So in this one, the function is not even a basic one. It's given as a table. So any manipulation I do, right, since the function is defined as a table, I expect my final answer to be a table. So this function, right, its table that we're going to basically build. But to do that, I first have to identify what transformations are occurring so I know how to manipulate these points. So for starters, I can see that we are basically taking all our x values, right, and we are going to the right 1, right? And so this impacts our x coordinates, right, moving right 1. Then what we're doing is we're taking, if you took the -1 out of there, I'm talking f of x. Well, f of x is y. So I'm basically taking all those y values, right, and I'm vertically stretching them and reflecting them, right, about the x-axis. And we vertically stretch it by 3. So this impacts our y values. And then last but not least, that addition of 2 basically means we move up 2. And that also impacts our y values. So how does this manipulate the data? Well, for starters, what I'm going to do, right, is the x's are easy. I'm going to take each one of these x values and I'm going to add 1 to each one of them. Because what that does is shifts everything to the right 1 unit. While I'm manipulating that, order of operations would say I'd have to do multiplication before addition. So I'm actually going to take all these guys and multiply them by -3. What that's going to do is do the stretching that needs to occur and doing the reflection. So handling these two, we have this new table right now. So my x values are -1, 1, 2, 4, and 7. My y values are -9, -6, +3, 0, and -12. So you can see that all the x values have been shifted to the right 1 because I added 1 to all the original ones. All my y data has been stretched out, right? I used to be 3, now I'm not, -9, right? I was 2, now I'm 6, I was 1, now I'm 3, but then the negative also caused everything to flip. So I was on the positive above the x-axis, I'm now below it and stretched. I was above the x-axis, I'm below it and stretched. Right? I was below the x-axis, I'm above it and I'm stretched. So you can get a feel that there's been a reflection. So the last thing we need to do, right, is to handle the up 2. So that means I'm going to take all these y values and add 2 to them because that creates an upward movement of 2. So my x coordinates are -1, 1, 2, 4, and 7. And my y coordinates are -7, -4, 5, 2, and -10. And so there's the new function, y equals -3, f of x minus 1 plus 2. If our function is given as this table, here's what that new function is going to look like. So we're essentially doing the same thing. We're just manipulating it point by point. So what about this graph? I would do the same thing, right? I would take this graph and I would identify some very special points. So -3, 2, right? How about we go ahead and I'll just come down here. Go to our low points. -2, excuse me, -1, -2, and then it looks like we have 1, 2, 3, -2, right? And then it looks like we have 5, 2, and then let me just do that endpoint, 6, 0. So those are some very key points along that graph. High points, endpoints on the interval, if you would, and high points and low points. We call those extrema. So how are we going to manipulate them? Well, looking at this new function, what they're asking us to do is add 2 to the x. So that means we're going to move to the left 2. We're multiplying f by 3, so that means we're going to have another vertical stretch, right, by 3. This affects x, this impacts y. And then we're going to go down 1. And that also impacts y. So we can do these two at the same time. So all my x values to move into the left, I'm going to subtract 2 from them all. And to get it to vertically stretch, I'm going to multiply all these by 3. So when I do that, here's my new table. So negative 3 take away 2 is negative 5. Negative 1 take away negative 2 is negative 3. 1 take away negative 2 is negative 1. 3 take away 2 is 1. 5 take away 2 is 3. And 6 take away 2 is 4. My y values, all of them are going to get multiplied by 3. So 2 times 3 is 6. That's a negative 6, a 6, a negative 6, a 6, and then 0 because we're not multiplying by anything. 0 times 3 is 0. So there you go. So we've handled these two things point by point. So the last thing is I got to impact all the y values. To get them to go down, I'm going to subtract them all by 1. So my x values are staying the same. Negative 5, negative 3, negative 1, 1, 3, and 4. But all my y values are subtracting 1. So 6 take away 1 is 5. Negative 6 take away negative 1 is negative 7. 6 take away negative 1 is 5. Negative 6 take away negative 1 is negative 7. Sorry about that. 6 take away 1 is 5. And 0 take away negative 1 is negative 1. And so now what I do is I had some important data points on this graph. There's their movement, if you would, on this graph. So any endpoints and highs and lows are now manipulated here. And we'll basically see that in this graph. So if I plot point by point, I got negative 5, 5. I've got negative 3 and negative 7. I've got negative 1 and 5. I've got 1 and negative 7. I've got 3 and 5. And then I've got 4 and negative 1. So as we move from high point to high point, you can basically see that this graph has been stretched out by a factor of 3. It's been shifted left, and it's been shifted down, right, by 1. And so that would be our answer for that. So we can handle any function, basic functions, non-basic functions, even tables, even graphs. We can manipulate them. But it all comes down to manipulating things point by data point. Alrighty? So more to do later. We'll get even more abstract.